Hello beta, good evening everyone. So beta, today we are going to go ahead and we are talking about the two variable regression model, chapter 3 of econometrics. In this we will be talking about hypothesis testing. ठीक है बच्चे? Okay. Now before we start this model, try to understand the following. Suppose I go ahead and I give you some regression equation. मैंने आपको कोई एक regression equation दे दी. मैंने आपको बोल दिया yi hat is equal to ऐसा कुछ बना दिया. I've gone ahead and I've made this. yi hat is equal to 432.4138 plus 0.0013 xi. Right, beta? I tell you that yi is the score obtained by a student, right? And xi represents the annual family income. ये मैंने आपको रिलेशनशिप दे दिया है. Now what done additionally ना, if you remember from the previous chapter, हमने क्या पढ़ा था बच्चे? We had studied that the population of the population जिसके बारे में पूरा डेटा सेट है, that is not at our disposal. वो हमारी पूरे हाथ में नहीं है. तो बिकॉज द पॉपुलेशन इज नॉट एट आवर डिस्पोजल, क्योंकि पूरी पॉपुलेशन हमारे हाथ में नहीं है, वी वर्क विथ सैम्पल डेटा सेट. तो हम क्या करते हैं ना, दैट फ्रॉम द पॉपुलेशन बेटा वी ट्राई टू क्रिएट अ सैम्पल. Because the entire population is not at our disposal, from the population we try to create a sample, and using the sample we give some estimate about this equation. We try to find out this equation, what this equation is and what this equation stands for, right? If you remember in the last class, I had also given you the formula to find these slope coefficients. So we had gone ahead and discussed that beta 1 hat will be y bar minus beta 2 hat x bar. And we had also discussed that beta 2 hat will be summation xi yi upon summation xi square, where x and y's will be the deviations from mean value. So we had gone ahead and we had discussed this in detail. हमने इस बारे में अच्छे से बात की थी what beta 1 and beta 2 stands for. Beta, today I want to ask and start with a very important question. And the question that is there is that how do I know that these values of beta will give me the best estimates of the population? मुझे कैसे पता कि population के best values निकल रही हैं in betas के through, right? How can I be sure on the basis of a single sample? इससे तो मैंने एक single sample generate किया है. How can I be sure on the basis of a single sample that in fact whatever equation I have formulated, this equation is going to be close enough to the population? This equation is going to be a good approximation of the population. मुझे कैसे पता population के बारे में एक sample के basis पे? How can I be so sure? Right? Well, to answer that question, we will have to go through a lot of things today. ठीक है? But to begin with, I want to start with the concept of stochastic versus non-stochastic. पहले हम एक चीज समझेंगे जिसे हम बोल देते हैं stochastic versus non-stochastic. Right, beta? Beta, stochastic means that anything which keeps changing. That means stochastic is anything which is random in nature, right? And non-stochastic, anything that is fixed. So if you go back to the example that we had taken in the previous lecture, you would remember that we were taking the income level at fixed values, 5,000, 15,000, 25,000, 35,000. So we were taking income values to be fixed. किसी level पे हम fix कर रहे थे income value. And given these income values, we were going ahead and we were finding the marks of students. So we were saying that, okay, if the income is 5,000, what are the different marks obtained by different students? assuming that all these students come from the families whose income is 5,000. वो सारे बच्चे जिनकी फैमिली की इनकम 5,000 है, उनके हमने मार्क्स यहाँ पे लिख लिए थे. We had taken the marks of all those students. Similarly, all those students whose family income was 15,000, we had gone ahead and taken their marks here, and so on and so forth. This is what we had gone ahead and we had done. यही किया था हमने बच्चे. So we were holding these income levels at some fixed values, na? So we could have said that the x's that we are talking about, these x's are assumed to be non-stochastic. Non-stochastic means fixed, means non-random. So the x values were assumed to be non-random values. But now, if you remember, the error is assumed to be random in nature. Right? This is for population regression function, and sample may we write it with EI or UI hat. So the error is assumed to be random in nature. Why is the error random? क्यों है error random nature में? Because error was the difference between actual and predicted values. And the difference between actual and predicted value could be positive also or negative also. कभी कभी positive था, कभी कभी negative था. So the difference between actual and predicted value could have been positive and it could have been negative. Since it could have been any positive or negative, therefore error was taking some random values. For example, if I take you back to this sample regression function, here I am taking income beta, here I am taking marks obtained. So what can I go ahead and I can do? I can take, okay, let the income be 1,000 or 5,000 से शुरू कर लेते हैं. Let the income be 5,000 and we were going ahead and we were taking the marks obtained by different students for the income level of 5,000. So we had taken marks here, marks here, marks here, marks here, marks here, marks here. Right? This was the average marks. Join that. But you can clearly see that this is where the actual value is more than the predicted value. So if the actual value is more than predicted value, the difference between yi and yi hat, which is ui, will be positive. यहाँ पे मेरे पास एक positive error बच रहा था, positive, positive. Whereas here you can clearly see that the difference between actual and predicted value is negative. Mane, you can clearly see that the actual marks obtained by student is say 20 and your regression say predicts that the marks is 30. So 20 minus 30, it means minus 10. So the error can be positive. The error can be negative. So the error was going ahead and it was taking random values. So we can say that the error, it was non-stochastic in nature, and by non-stochastic, I mean that the error was random in nature. Clear? अब बेटा देखो. Now when I talk about the value of yi, so what is the value of my yi? Yi can be written as yi hat plus ui hat. Predicted value plus error term gives you the actual value of yi. You know that yi hat is nothing but beta 1 hat plus beta 2 hat xi. Beta x is to fixed hai, beta is constant hai. So we know that these x's and betas, this part, this is a fixed part. This is non-stochastic in nature. But if I look into this part now, I can clearly see that this is stochastic. This is random in nature. So any fixed thing plus something which is random, fixed plus random will give you a random value. Fixed plus random to random hi dega na. So we can go ahead and we can say that the final yi values, they will become random in nature. So yahan se what have we derived? We have derived that the x values are assumed to be non-stochastic. Right, beta? The UIs, they are stochastic, right beta? And the YIs, these YIs, because these are xis, some function of xis plus UIs, therefore they also become stochastic in nature. ये भी random हो जाते हैं. Now, if you for a second revisit the concept of random variable, अगर आप थोड़ी सी देर के लिए random variable के बारे में सोचेंगे, you will find out that a random variable is any variable which is associated with probability distribution. You remember from stats class beta? Any variable which is random in nature, कोई भी variable अगर वो random है nature में, it will have a probabilistic or a probability distribution associated with it, right? So because in our case, we can clearly tell that the YIs and the UIs, they are random in nature क्योंकि ये random variable हैं. These are random variable, so we can go ahead and we can tell that these will have a probability distribution associated with them. Clear हुई बात बच्चा? तो if I tell you that the values of y have probabilistic assumptions or the error terms have probabilistic assumptions, you will say yes. Because they are random variable, any random variable will go ahead and it will have a probability distribution associated with. Clear हो गई बात? Now, but now we want to focus on the actual part of this chapter, which is called as classical linear regression model. क्या बोल देते हैं हम इसे? Classical linear regression model. What is a classical linear regression model? So a classical linear regression model is any model which, word पढ़ो, which is linear in nature. तो इसकी कुछ assumptions हैं बेटा. Let us start with the assumptions of the CLRM model. Assumption number 1, that the regression model is linear in parameters. The regression model is linear in parameters. It may or may not be linear in variable. ये पैरामीटर में लीनियर होता है, वेरिएबल में लीनियर हो भी सकता है और नहीं भी हो सकता. To give you an example of this, बच्चे, let us go ahead and say yi is equal to beta 1 plus beta 2 xi plus ui. We just want to make sure that these betas come linearly. मुझे सिर्फ ये श्योर करना है कि ये जो मेरे betas है ना, ये linearly आए. I just want the parameters to come linearly. So it is fine if my model looks like this. Yi is equal to beta 1 plus beta 2 1 by xi plus ui. No problem. If my model is ln yi is equal to beta 1 plus beta 2 ln xi plus ui, no problem. If my model is 1 by yi is equal to beta 1 plus beta 2 xi plus ui, no problem. The only assumption that we are making here is that these parameters, ये जो मेरे betas हैं, these betas should be coming linearly. इन betas का linearly आना जरूरी है. That is my first assumption. A regression model should be linear in parameters. Beta, second assumption. The second assumption says that the explanatory variable xi, it must be uncorrelated with disturbance term ui. So now there should be no relation between xi and ui, right? Xi and ui, covariance between xi and ui should be 0. Xi और ui का कोई relation नहीं होना चाहिए. What does this mean? But it means that suppose मैं यहाँ पर xi को I have taken to be the income level, हाँ, and I am predicting the marks of the student. तो ऐसे ना हो that whenever the income level is below say 20,000, I am always predicting marks with less value. And whenever the value of x is more than 20,000, I am always predicting marks more than the actual marks. ऐसा नहीं होना चाहिए. There should be no relation that I will be able to form. ऐसा कोई relation ना बने that whenever the income is more than 20,000, my model always over predicts the marks. And whenever income is less than 20,000, my model always under predicts the marks. ऐसे कोई relation नहीं बनना चाहिए. The two things should not be correlated with each other. The covariance between xi's and ui's should be zero. There should be no relationship between them. Am I clear with this, बेटा? तो एक और चीज है जो बहुत आसान है समझनी यहाँ पर. बेटा, try to understand that x's are assumed to be fixed. Fixed means they're assumed to be non-stochastic. हाँ बेटा. And ui's are fixed to be supposed to be random. Random means stochastic. Beta, the formula of covariance is summation xi minus x bar ui minus u bar. ये formula होगा covariance का divided by n. अगर ये x's fixed ही हैं, if these x's are fixed, तो anything that is fixed cannot be related to anything which is random. ये एक बहुत basic चीज है. Whenever you go ahead and find variance also of a constant number, of a fixed number, it is zero. So if I am assuming that my xi's are fixed, अगर मैंने ये assume ही कर लिया that xi's are fixed, then by the very assumption that xi is fixed, this assumption is fulfilled, right? So if xi's are assumed to be non-stochastic in nature, if it is assumed to be a fixed number, then this assumption that the covariance between xi and ui is zero is automatically satisfied. इसमें हमें कुछ और करने की जरूरत ही नहीं है, right? So this assumption is automatically satisfied by assuming that xi's are in fact non-stochastic. So let's write this down, बच्चे. So please write down that since we are assuming that xi's are non-stochastic, hence this assumption automatically holds true. Clear, बच्चे? Clear है? Second assumption? I hope this is making some sense, huh? Achha, now let's go to the third assumption. So assumption number 3. The third assumption goes ahead and says that whenever you will find the expected value of the error term given ui's, it will always be 0. थोड़ा words में लिख देते हैं. The conditional mean of error given xi's will be 0. Let us try to explain this thing, बच्चे. To see that, I have taken my x here and I have taken my y here. But this is my regression equation. ये जो मेरी regression equation है ना, this is of the format e y given xi is equal to beta 1 plus beta 2 xi. इस form में ये regression equation. ठीक है? But try to see that I have this as my xi. Suppose xi है income. So I have fixed my income as 5,000. And again, yi is the marks obtained by student. So for all students whose family income is 5,000, मैंने उनके marks को jot down कर दिया. So I have written that, okay, their marks can be this much, this much, this much, this much, this much, this much. Right, beta? Try to see that जो हमारे average marks आए होंगे, given this income level, I have joined those and I have got my regression equation line. मुझे मेरा ये regression equation line मिल गया. There are some marks which are above the average marks. So here my yi is greater than the predicted marks. That means I am making positive error. There are some marks which are below the predicted marks. So my marks predicted, I am predicting more than the actual marks. So error is actual minus predicted. So in this case, my error will be negative. So I am going to go ahead and have positive error. I am going to go ahead and have negative error. कुछ positive errors हैं, कुछ negative errors हैं. But on average, if I have some positive and some negative errors, don't you think that the summation of these error terms will turn out to be 0 on an average? Right? This is exactly what we are going ahead and seeing. We are saying that yes, on an average, the errors turn out to be 0. There will be some errors which will be positive. There will be some errors which will be negative. But on an average, the sum of these errors, it will come out to be 0. ये sum 0 बन जाए. Right? Okay, beta. The next assumption. Assumption number 4. So the next assumption that we have about this model, it is called as homoscedastic model. Okay, beta. Try to understand this thing. See, bache, homo means same. Scedastic means variance. So when I say homoscedastic, we means equal variance. So what is this assumption saying? This assumption says that the variance of the error terms is assumed to be constant. हम ये assume करके चलते हैं कि हमारे error terms का जो variance होगा, it will be constant. Right, beta? Let me try to go ahead and explain you this through 2 diagrams. So try to see this thing. Bache, I am taking x here, y here. Again, I am taking x here, y here. This is my sample regression function and sample regression function. Clear, beta? Beta, I hold x at some value and I try to plot all the values of corresponding y's. Then suppose x is fixed at x1. Then I fix x at x2. फिर से मैंने सारा y's बनाया. Then x is fixed at x3. फिर से मैंने सारा y's को jot down किया. बेटा, to understand variance of a data set, ध्यान से समझना, हाँ? Variance is how you are spread around your mean value. So if I tell you that this is my mean value, variance would mean how I am spread around the mean. What is this gap around the mean? And if 2 data sets have the same mean, अगर उनका mean same ही आ रहा है, this also has mean of 20, this also has mean of 20, they can still have different variance if this spread differs. जैसे देखो यहाँ पे spread differ कर रहा है ना. So if they have equal variance, the spread would look out to be the same. देखो, they look very similar. जितना यहाँ spread है, उतना यहाँ spread है. If I find something like this, then I will say, हाँ, data set has equal variance. ठीक है, same variance लग रहा है. I see that the variance is similar. But if I see something like this ना, जैसे अगर मुझे ऐसा कुछ मिल जाए, then I can clearly see that, okay, although the mean was same, but around mean spread has been very, very different. And therefore the variance is different. Variance बहुत ही अलग रहा होगा. Now I am coming back to the same point here. We have already assumed that error terms have 0 mean. तो चाहे मैं error x1 के लिए plot करूं, x2 के लिए या x3 के लिए, we assume that all of them have a mean of 0. Expected value of the error given xi, we have assumed that to be 0. Now, to see the spread, what I can go ahead and do now, I can just make a distribution. And अगर ये distribution more or less equal लगेगी मुझे, the shape seems to be similar, ये and ये, they seem to be same, then I will call them as homoscedastic by looking at the data set. Supposedly, what happens, I take x1 here और x1 के around मैंने यहाँ पे plot कर दिया. I take x2 here, x2 से related जितना values था y का I plotted. I took x3 here, x3 से related जितना values था I plotted. Now, when I'm trying to create the spread of the error term, so I see that the spread here comes out like this, but the spread here comes out like this, and the spread here comes out like this. So clearly, by looking at the data set, you can notice now that the spread is not the same. The spread is very, very different. So if the spread is different, we can go ahead and say that this is heteroscedastic. Beta, hetero means different and scedastic means variance. So we can clearly go ahead and say that this represents heteroscedasticity and this represents homoscedasticity. Acha, heteroscedasticity mein how do I write this mathematically? When I can say that variance of the error term is sigma I square. ये I लगा दिया ना बच्चे. It means that this differs. मतलब शायद यहाँ पे variance sigma 1 square रहा होगा, यहाँ पे variance sigma 2 square रहा होगा, यहाँ पे variance sigma 3 square रहा होगा. It varies with the value of I. So if it varies with the value of I na, then I can go ahead and say that this is heteroscedastic. And if there is no I, कोई subscript है ही नहीं, it means this variance is also sigma square, this variance is also sigma square, this variance is also sigma square. So if the variance is the same, I can say na that therefore it is going to be a homoscedastic data set. अब एक और बात है, बहुत बहुत ध्यान से सुनना मेरी बात को, इट इज वेरी इंपॉर्टेंट, सुपर सुपर इंपॉर्टेंट है बच्चे. अच्छा एक बात बताओ, आई एम सेइंग वाई आई इज इक्वल टू वाई आई हैट प्लस यू आई. द एक्चुअल वैल्यू ऑफ वाई इज इक्वल टू द प्रिडिक्टेड वैल्यू ऑफ वाई प्लस द एरर टर्म्स. बेटा, इफ आई वांट टू फाइंड द वेरिएंस ऑफ वाई, it will be the variance of yi hat plus ui. Clear? So if I were to go ahead and I were to do that, ध्यान से सुनना, it is going to be variance of yi hat plus variance of ui plus 2 covariance yi hat ui. Beta, yi hat is nothing but it's a function of xi. yi hat to beta 1 hat plus beta 2 hat xi tha. It was a function of xi's. Xi's are assumed to be fixed in nature. They are assumed to be fixed in nature. If they are assumed to be fixed in nature, अगर मैं xi's को given मानूं, अगर मैं उनको fixed मानूं, then I can assume that the variance of xi will be 0. Or constant, there will be no change in the variance of xi. Fixed रहेगा, right? Xi's are fixed, they are given, they are non-stochastic in nature. If they are non-stochastic in nature, then because they are fixed, then they cannot cause yi to change. वो तो खुद ही fixed है, तो वो yi को कैसे बदल सकते हैं? How can they bring variance in yi if they themselves are fixed? तो क्योंकि yi hat is a function of xi and xi itself is assumed to be fixed, so yi hat cannot be a source of variation in y. तो yi में variation क्यों आएगी बेटा? Why will there be a variation in y? There can be a variation in y only due to the error terms. It is very tricky. Try to understand this thing. There can be variation in y only due to the error term. क्यों? Why will that happen? अरे बहुत simple है ना, because this yi hat is a function of xi. xi itself is assumed to be given, xi itself is assumed to be non-stochastic. अरे जो चीज फिक्स्ड है वो दूसरे में कैसे वेरिएशन लाएगी? मैं ही, इफ आई एम फिक्स्ड इन माई थॉट्स, अगर मेरा ही दिमाग फिक्स्ड है तो क्या मैं आपका दिमाग बदल सकती हूँ? नहीं. सो if xi is fixed, it cannot bring variation in yi. So we can say that the only, please write this down beta, source of variation in yi is ui. yi में वेरिएशन आ ही इसलिए रही है क्योंकि ui प्रेजेंट है, क्योंकि एक रैंडम टर्म प्रेजेंट है विच इज ui. So we can say that given xi, the variance of yi is the same as ui. तो variance of yi वही होगा, it will be the same as the variance of ui. Right? Is that clear? तो एक और लाइन लिख लो बेटा, that the conditional, therefore the conditional, बेटा unconditional की बात नहीं हो रही है, कंडीशनल्स की बात हो रही है, क्योंकि हम xi को कांस्टेंट होल्ड कर रहे हैं ना. होल्डिंग xi कांस्टेंट, इतने के लिए ही हमने उसका वेरिएंस निकाला है, फिर xi को यहाँ पे रखा, फिर वेरिएंस निकाला, तो हम कंडीशनल वेरिएंसेस निकाल रहे हैं. वी आर फाइंडिंग आउट कंडीशनल वेरिएंस. सो वी कैन गो ahead and say that the conditional variance of ui and yi are same. The conditional variance of ui and yi are same. That is why a lot of times diagram में we don't find the variance of ui, rather we find out the variance of yi only. हम directly yi का ही variance diagrams में दिखा देते हैं because of the concept that the conditional variance of ui and yi, they are assumed to be the same. Am I clear with this? This is very, very important concept. ठीक है बच्चे. Now, the next assumption, assumption number 5 of the CLRM model is that there is no correlation between the error terms. There is no correlation between the error terms. That means we can say that there is no autocorrelation. That means the covariance between ui and uj is 0. Try to understand. Imagine that today I ask you, beta, what do you think will be the weather tomorrow? आपको क्या लगता है क्या टेम्परेचर रहेगा कल? You go ahead and you tell me, ma'am, I think it will be 28 degrees. But the temperature is 30 degrees. You have underestimated the temperature. Again, tomorrow I ask you, beta, what do you think the temperature will be today? फिर से आप सोचते हो कि I underestimated the temperature by 2 degrees. Ma'am, it will be 30 degrees. It turns out to be 32 degrees. There is a pattern that can be seen. You always go ahead and underestimate the temperature. अगर कुछ ऐसा है, if there is a systematic relationship between the error you make, like in macroeconomics, there is a systematic error made every time in adaptive expectation. हर बारी, every time people will make mistake in a systematic way. हर बारी वो पिछले साल की इन्फ्लेशन को मद्देनजर रखते हुए इस बारी इन्फ्लेशन कैलकुलेट करते हैं. Every time they miscalculate inflation and they always calculate lower inflation. So we see that there is a systematic relationship between the error that they make. If there is a systematic relationship between the errors, if the errors are related to each other, that today I underpredicted, tomorrow also I underpredicted, day after tomorrow also I underpredicted, हर रोज मैं negative prediction कर रही हूँ, right? If there is some relationship I can see, then there is existence of autocorrelation. But if there is no relationship I can see, today I underpredicted, Tomorrow I over predicted, then again I over predicted, then I under predicted. There is no pattern. Randomly things are happening, right? So if there is no systematic relation between the error terms, you are predicting, but the prediction is happening random nature, then we will say that there is no autocorrelation that exists. Then there will be no autocorrelation. So to show this, what we can do na beta, we can take error term in period I and period J, and if they are randomly spread, there is no relation between them, then this diagram says that there is no autocorrelation. But if I go ahead and I again take UI here and I take UJ here, and I notice that there is, the spread is like this. So I can clearly see now that when this is taking positive values, this is also taking positive. When this is taking negative value, this is also taking negative. So I can see that there is a positive relationship between the two now. So this is a positive autocorrelation. Similarly, if I go ahead and I plot the error terms, and I see a relationship like this, ऐसा कुछ बन रहा है. That means whenever I have negative error in first period, it will be followed with positive error in the second period. Whenever I have positive error in the first period, it will be followed with negative error in the second period. That means I see a negative relation. Nah? This is a negative autocorrelation. So the assumption of CLRM model is that there should be no correlation between the error terms. ठीक है, अब फिर से समझने की कोशिश करो बेटा. We know that ultimately yi, value of y in period I, is changing because of ui's. क्योंकि yi hat fixed है. yi was yi hat plus ui. This was a function of xi. Xi is fixed in nature. So yi is changing because of ui. And yj is changing because of uj. Right? So indirectly, when I say that we don't want any relation between the two error terms, indirectly I am saying that we don't want any relationship between the two y's also. Right? So we are going ahead and saying that since, फिर से same relation beta, that since x is fixed, y can only vary when u varies. y सिर्फ तब वेरी करेगा जब u वेरी करेगा. Right? So therefore, I can go ahead and say that if the errors are not related with each other, y will also be not related to each other. But a last assumption of the model, assumption number 6. This assumption says that there is no specification bias. Right, beta? Beta, no specification bias का क्या मतलब है? No specification bias means that you should not be having any problem of giving the correct model. Your model should be absolutely correctly specified. Just for example, if I tell you that, let's say the demand of cars, it is a function of, say, the price of the car, price of automobile, and it's a function of the consumer income. So I have told you that the demand of the car is a function of the price of the car and the consumer income. मैंने ये दो factors लिए हैं. But what factors like advertising? By car is completely oligopoly model. And in oligopoly, we can have a role of advertising. What about a factor like the cost of petrol? What about factor like loans available or not, financing cost. These factors can also affect the demand of the automobile now. So when you do not go ahead and when you don't give the correct model, when you miss out on the variables which you should have written, जो variables मुझे मॉडल में मेंशन करने चाहिए थे, अगर उन variables को मैं मॉडल में मेंशन नहीं करती हूँ, if I don't mention the variables I should have mentioned in the model, then that's the problem of specification bias. But these are the assumptions that we need to go ahead and follow. There is one extra assumption which Gujarati does not talk about in his book, which is no multicollinearity. इसको वो CLRM assumptions में नहीं लिखते हैं, but it is an important assumption. This just says that the xi's, they should not be correlated with each other. कौन से xi's? जैसे for example, if I tell you that, you know, my income is a function of consumption and savings, then these are completely related with each other, because I know that saving is nothing but income minus consumption only. तो savings हमेशा consumption के साथ related ही रहेगी. They are highly correlated with each other. Then this will be a wrong model to make. But if I go ahead and I tell you that, okay, my income, it is a function of my class 12th marks, or it's a function of my graduation, and my income is also, say, a function of something else. Say, let me tell you, my income is a function of the kind of service sector I am into, whether I'm into IT, whether I am into teaching, किस चीज में मैं हूँ, my profession, and some other factors. And there is no correlation between these factors. Then it will be a good model to work with. तो जो भी मेरे xi's है, like here, one xi is price of automobile, and this is in the income of the consumer. And these may not be related to each other too much. थोड़ा relation होगा, because when the income of consumers increase, the car prices will also increase. But they will be not very strongly related to each other. So, agar there is not very high multicollinearity, then it is a good model to work with. ठीक है बच्चे, let's just revise all the assumptions we have done now. तो क्या assumption है? The first assumption we had, this assumption was that it should be a model linear in parameters. The second assumption is that the covariance between xi and ui should be 0. The third assumption is that on an average, the errors should be 0. The fourth assumption is that it should be a homoscedastic model. The fifth assumption is that there should be no autocorrelation. The sixth assumption is that there should be no specification bias. And at last, there should be no multicollinearity. So these are some of the assumptions of the CLRM model. I hope you are absolutely